Welcome everyone. Today we have the second webinar from the series of building our power in the age of artificial intelligence. And those webinars are intended for software testing and quality assurance professionals who are entering this world of artificial intelligence and how to test it, what to make of it, how to learn it, and how to conquer it. Today we are joined by our wonderful panelist, Aprajita Mathur. She's a senior manager of Bioinformatics software test in Guardant Health. Raj Subrameyer, he's principal consulting of ChaiLatte. Davar Ardalan, founder of IVOW AI, and Kashyap Murali, AI and deep learning developer, dean of the Princeton School of AI. This series are sponsored by IVOW, Test Leadership, Quality Leadership Institute, Test Masters Academy, and Girls in Artificial Intelligence. And we are starting with Aprajita, who is going to introduce herself, and then all our panelists will introduce ourselves as well. Welcome, everyone.
Hi, everyone. I'm Aprajita. I'm a mom of a 3-year-old, and I'm also a speaker and inventor. I work for fun and for excitement at Guardant Health. I manage the Bioinformatics software test team. At Guardant, we are creating new technology to conquer cancer with data. And I'm very excited to be here for the talk today.
Hi, everyone. I'm Kashyap Murali. I'm an AI researcher and a high school student here in Princeton, New Jersey. I'm also very excited to be here and glad to talk about all things AI, and it's a topic that I'm very passionate about, and glad to be working with everybody else here.
Hi, everyone. My name is Raj Subrameyer. I help companies by doing content creation, social influencer marketing, and providing thought leadership to bridge communities with products, and also help people to get to the next level in their tech career path. So that's about me.
Hi, I'm Davar Ardalan. I'm a mother of 8, and I am the founder of a startup on AI and culture. And I thought, if it's okay, we're just going to play this video. It really talks about how I got into this field, especially a year ago when I walked into my granddaughter's living room and she asked me to meet her friend Alexa. So if you can play the video.
A year ago, I walked into my granddaughter's home and she said, "Aziz, come and meet my friend Alexa." And it dawned on me, that's why we created Culture IQ, for all the ways she'll engage with AI in her lifetime. Our robust API platform is optimized to provide cultural intelligence training in B2B and B2C contexts, like travel, tourism, and e-commerce. Our co-founders are engineers, journalists, and designers with experience reaching millions at NPR News and NASA. We enhance the cultural fluency of conversational interfaces. With IVOW AI, you invest in the value of people.
Cool. And we'll talk more about what we're doing later in the webinar. Thank you.
So for today, we'll be covering 2 topics. We will be talking about what, how, and why neural networks work. This would be covered by myself and Kashyap. And then we will be moving into why diversity in AI is important, and what is the algorithm data set challenge, and that would be covered by Raj and Davar. And then we'll open up for question and answers. Okay, so everyone's heard the term artificial intelligence, and if you really think about what is the best possible AI out there in the world today, if you want to think of it, you might think about your phone, you might think about your car, but actually it's the human brain. Every single one of us has it. And it is a very powerful AI system. All the AI research that we have right now or that we're doing is based on how we understand our brain or not understand our brain. So what is really AI? This is from Wikipedia directly. So in computer science, artificial intelligence, sometimes called machine learned intelligence, is the intelligence that is demonstrated by machines, right? In contrast to what a human would show. And though there's a lot within researchers and within the community, there's a lot of conversation around what type what are the different AI systems, most researchers categorize them into three broad categories. The first one is called ANI, which is narrow intelligence. And this basically means that your artificial intelligence system is focused on a narrow task or a simple task. The next level is artificial general intelligence, which is similar to humans. And the third one is super intelligence, which is smarter than humans. And so where are we today? So if you look around you, there is enough AI, cars, Google search, email spam filters, your phone, all of these are examples of AI that we use every single day today. And are we really at the stage where, you know, you would get AGI or like the final level of artificial intelligence? So where are we today in this world? Not really. We are really at the very first step of that, if you call it a pie, at the very crust, which is narrow intelligence. All of the examples that I shared right now are examples of narrow intelligence. What does that really mean? We haven't really achieved anything that is same as human or smarter as humans. Most of the AI systems that we have do something simple or do a narrow task. And the question now becomes, is it really a narrow task? Is it really that simple? So if you were to ask a computer how to calculate the square root of a number, it can do it very, very fast. Can I do it? No, I cannot. So then is that really simple or not? Well, let's think about it. Humans have evolved over millions of years to be where they are. And we have done a pretty amazing job with our brain and our bodies. So we have evolved in a different way. Machines have evolved in a different way. Machines are very good at calculating numbers. So this is not something that we have evolved into. We don't do math every day at that complex level. What we do is something like this. This is a book that my son reads. And if I ask my son, hey, can you tell me all the animal pictures? Can you describe what these animals are? He's going to be able to describe them pretty easily. Can I develop an AI system which can identify each of these animals pretty easily? No, it's pretty difficult to do that. So what is very simple for humans, or what we might think is very simple for us, is actually very, very complicated for machines. And why is that case? So let's see. Those were distinct animals. However, if I was to say, can you identify a macaw in all of these pictures? Now that is a pretty challenging task, not for my toddler, but for an AI system. And so we have to really think about it and say, okay, what are we really building here? What are we really trying to do? So most AI systems are based on, and you might have heard this word, neural networks or neurons. And the concept came into about, it is based off of how human brain works. And so how does our nervous system really work? Our nervous system is comprised of small neurons, cells, and they communicate to each other through electrical signals. And it is a very big, massive network of these cells. It was first thought about in 1943 when, two of these neuroscientists came around and they came up with the concept of artificial neural network. It was based off of human brains. And what is a neural network really? So a neural network should be able to approximate a given input into a good output. So what I would expect a neural network to say is, okay, does this look like a macaw? I think 99% it is a macaw, right? Or to have a very complex definition, you can say a neural network is defined as a complex, adaptive computing system that consists of a number of simple but highly interconnected elements called neurons. Information is processed collectively in parallel throughout a network of neurons to produce a good output. Notice that I have good in quotes because it is really a good output, may not get a perfect output. So going to the basics of neural networks, what they are, we're going to talk about the very, very basic structure, which is called a perceptron. And what does that really mean? So this is the basic unit. You add multiple perceptrons to make a complex neural network, and we'll talk about one single perceptron today. So let's see. This is an example perceptron. It has multiple inputs. And then each input has weights associated with it. What does that really mean? What does a weight really mean? A weight is how important each of these input is relative to the final output. Then we have something called bias, and we'll talk about that a little bit more. We have something called a combination factor. What the combination factor really does is it takes all the inputs, their relative importance, the bias associated with this specific structure, and then put it into one single value. That is what a combination function does. An activation function takes all of this, and then what we said, takes an input and converts it into a good output. That is what an activation function does. And these are words that are commonly used within AI and in algorithms. And we'll see a simple example of this. So everybody has probably heard or used an AND function, which is pretty simple. So if you have, this is the matrix for an AND function. So if you have two inputs, A and B, and you say an AND of this, the output is AB, which means if I go in binary, if this is a 0, 0, it will lead to a 0. If it's a 0, 1, it'll lead to a 0. If it's a 1, 0, it'll lead to a 0. And if it's a 1, 1, it'll lead to a 1. And if I was to convert this into a neural network, which contained only one single node, what that would look like is that I would have inputs where the weight of both of them would be 1, because we have to consider both A and B, they're both equally relevant, right? And then I would add a bias here. What this bias really does is it helps us in situations where everything is 0 or everything is 1. It will let us drift the final outcome to either a positive or a negative number, because what I'm expecting out of this, sorry, in this case, a 0 or a 1. So this is something that is interesting, and I want you guys to be aware of it and maybe play with it when you guys get the time. So this is a open, I did not make this. This is out there. You guys can go play with it. It's called Playground with TensorFlow. And what it allows you to do is create very extensive or simple networks, artificial networks, and you can play with them to see how different things impact them. And I'll show you an example. So for example, what I just described, I have two inputs. In this case, the weight of this is 0.47. This is the relevance of this. This one is 0.22. So what I'm basically saying is X1 has higher relevance than X2 when I'm trying to determine the output. And these are many other things that we can do to neural networks. Kashyap will be talking to some of them later in the webinar. And if I hit play, it will show me how this model really trains and what it's trying to do. So this is something that's interesting, and I hope you guys can go and play with this. Okay, so what we just described, or what I just showed to you guys, is what's called a feed-forward neural network. What does that really mean? So what that means is that you only have one layer of inputs. So you go from inputs to outputs, and that's it. And it's only moving in one direction. So there's just going from inputs to outputs. There's nothing else happening in that network. There are no loops. There's no feedback. So if we're talking about artificial intelligence, if we're talking about machine learning, and the basic concept of that is that a machine should be able to learn by itself, then how did we really achieve that? Because all we did was we put a mathematical calculation and we said input X goes to output Y, right? So how does that feedback really work? And more than one is the feedback aspect, and the second is an AND gate is pretty simple. But if I was to develop a very complex AI system, then how would I come up with the weights? How would I come up with the values that I would put for biases? How would I really optimize my algorithm? What would I do? So I'll take some real life examples to talk through this. So what this is really called is what we try to do is we will try and within your AI models or within your machine learning models, you will try to, there are 3 different types of learnings and 3 different types of applications. So we'll go through one of these at a time. The first one is a supervised learning. You can think of this as show and tell, like the one I demonstrated, which is pretty simple, or classification. So for your machine or for your algorithm, it's a classification application. It's trying to classify an image and it's saying, okay, is this a dog or a cat? Is this Aprajita or Davar, right? Unsupervised one is when we don't know everything and within your inputs, and we're trying to determine a pattern. So for example, you have a lot of inputs, but we're trying to find a common characteristic between all the inputs that are coming in. So if you ever received an email from a credit card that said, hey, did you really make this purchase? What does that mean? They are basically scanning through your transactions and trying to find something that is an anomaly. They're trying to find something that doesn't fit your regular purchase system or your regular purchase. And so they say, hey, is this a theft? That's a machine learning algorithm in place. And the third one is reinforced or regression. And this is really based on observations. So you keep observing, you keep learning based on past and future. And this is really, common in something as simple as, not as simple, but something that we wear every day, which is like an Apple Watch, right? Where it's monitoring your heartbeat and say it detects something that's not based on your future and past. It can say, hey, look what just happened. So what is really machine learning? We kind of covered this, but machine learning is a small aspect of artificial intelligence, and it's really building algorithms and building models, mathematical models that can make predictions so an input going to a good output. So we talked about a very simple perceptron, which only was one single neuron, but this is a figure. If you search for neural network, you will find this on Google pretty easily. What this really means is that in real life, the ML systems that we create, they are not just one single node. They're actually quite complex. And what that means is they have multiple inputs and what's called hidden layers. So they have multiple hidden layers, which finally goes into output, right? And what this means is you're taking, for this input, what this means is you're taking this input, it has all these weights, remember, that we talked about? And all of these are used to go through, all of these will go through this hidden layer of neurons. This layer is going to take into account all of this, all of this, all of this, so on and so forth. And then keep propagating it forward until you get a final output. So we'll take a simple example. Say you have an input 1, right? And you have this image and you're trying to say what number it is. And these are all the possible values it can have. When you ran it through a simple algorithm, it came up with these values. Now, in order for us to determine how our algorithm did, what we do is we calculate our output to what the target is. This is pretty common in testing as well, right? You want to make sure that what's your expected outcome meets your actual in your test case, for example. And so here you see, okay, this went, the algorithm identified this as a 0.8, but it should be a 1. What this means is that there's an error in our calculation and our algorithm hasn't been able to detect this quite correctly. So this is the error associated with it. And all algorithms try to minimize this error to the minimum. So we're trying to go from 0.2. This might be the first time this algorithm was run. And we want to optimize it such that we go from 0.2 to as low as we can go, right? And that is where the algorithm called backpropagation comes into place. What does that really mean? What that means is we still move along our hidden layers of neural networks. One layer learns from the other, so on and so forth. However, once you get the first output, you don't say that's the final output. It's like an intermittent output. And before you even do that, you calculate the difference between the output and your desired value, and then you feed it back to your network. And this is where really the learning of a network begins. And the network goes, oh, I am not there yet. I need to adjust stuff. And what does that mean? It means I need to adjust these weights. I need to adjust my biases in order to predict better. And that is basically what's written on this slide. Is back propagation is the algorithm is optimizing your weights and your biases in order to come up with the best possible outcome. These are not the only type of neural networks that are out there. There's a humongous amount of algorithms out there. This is an example. You can go to this website and find more about these. Now, let's think about, say we came up with an algorithm, we started, but how do you, what does it take to train an algorithm? What does it take to train a model? So there are 3 types of data sets that are used commonly in the industry to train a model. The first one is a training data set, the second one is a test data set, and the third one is a validation data set. The training data set is used to fit the model, which means this is what the model uses to train itself the very first time. This is what it uses. Then you test it on the test data set and you say, okay, let's see how well did we train the model? And the validation data set is really predicting something that the model has not seen before, trying to see how it really does in the outside world. And then 2 terms that I would like to describe would be underfitting and overfitting. These are important. And what underfitting really means is that your model basically, let's take this for example. So what it really means is that you trained your model, but it was trained in such a fashion that it is not doing well on the training set. It can't even identify well with the training set. Overfitting means that you trained it so much on the training set that when you give it an actual data set, it's not able to go from input to output. It only does well on the training set. It doesn't do well in real life scenarios. This is what a balance looks like. And the next thing that's important is what are you really training on? And data is very, very important. So bad algorithms trained on lots of data can overperform good algorithms trained on very little data. So data is a very, very important piece to neural networks and to AI. So as important as your algorithm. So here's an example. So say, for example, I created an algorithm that tells me if it is if I put in a word, and it tells me if it's a dog voice, right? And so imagine that I trained it on this set, and it still covers most of the dog voices in the world. However, in my native language, the dog goes, bah, bah, and it's not here. So it's never going to be able to come up with that outcome. If I give it the input bow wow, it's gonna say, I don't know what that means. I don't think it's a dog voice, right? So data is very important. And I will hand it over to Kashyap now.
Thank you so much, Aprajita. So now we're going to just briefly talk about how we can look at the bias within these AI models. So first of all, if we take a look at natural language processing in not ancient, but relatively older language models, you can see that the words aren't even found. So that's like from 2014, etc., the word vector. Certain words are completely vanished within the data set, which itself is a pretty big problem. Now, in this really cool visualization from TensorFlow, we can perhaps search up the word that I'm talking about, Draupadi, which is a Indian princess from an epic. And you can see that there's 0 matches for that word because it doesn't exist. And even as Aprajita said, let's perhaps try expanding the data set from 10,000 words to 71,000 words. It's a bigger model. And we do the same exact search and there's still 0 matches, just thus showing that some data doesn't exist. However, not to discredit the model, there are also some possibilities where cultural diversity is included. As we type in Maya Angelou, and then we see the matches for Langston on the right, Maya on the right, etc., thus showing that it does exist. Now let's take a look at a relatively modern model. We'll call it BERT. And for here, every word is identified. There are no missing words. However, it does it by doing this kind of splitting algorithm. As you see, the word is split into 4 different chunks. Still, although it's not as bad as the first one where the word isn't found whatsoever, it is a bit better such that, it still has its own can you pause the video for a second, AP, if you don't mind? It still has its own misgivings such that it'll misidentify, different words because it'll have 4 different pieces. It's just one word. Draupadi is one word. Yet it'll make it into 4 different chunks, which is not right. A bit better, however, not yet completely there. Now we can move on now to the images part. Yeah. So quickly, I want to talk about on the left over here, Facebook AI Labs research team published a pretty cool paper on how socioeconomic status, as it's written, is a differentiator for object recognition. So in not first world countries, but relatively poorer countries, you can see that the soap itself is identified completely different. Because on the left, I see Azure, Clarify, Google. These are all models from big companies. You can see that it's identified as, food, cheese, bread, et cetera, et cetera. However, soap on the right is identified as, you can actually, it does it correct. As you can see, healthcare, lavatory, sink, all that stuff is identified. Thus showing how and you can see the revenue, the income is like $268 to $88 per month, as opposed to $90 per month. Thus showing how the difference in data makes a big impact for how the model learns and trains. However, another aspect is when regards with cultural diversity and cultural IQ, which Davar and Raj are going to take over shortly. This is actually a sculpture of Draupadi, which I showed in the previous example, which we can see how the images can transcend that of simply paintings and art, etc. Also sculptures and other forms of communication and visualization from generations past can definitely be used to represent and the cultural diversity and at least include a smart sense of cultural IQ. And this can be done through formats such as a dataset challenge, which I mentioned Davar is going to be talking about in the future. One small note, when AP said bias in the previous slide, that is with relative to the technical term of the neural network. However, the bias here is with the human bias that we're talking about, as in the bias that we're leaving out certain cultures, certain folklore, etc. And as Aprajita perfectly mentioned, it's all about the data. So the data is the answer to this solution. Thank you.
Cool. Thanks, Kashyap. So AP and Kashyap, they gave a good introduction about AI, how it works, and how biases, when you include them in the data set, what kind of outputs you get. Now, I'm going to talk about how we developers and testers can ensure all these AI-based systems we interact with has diversity included in it. So that's what we're going to talk about in the upcoming slides. So most of the AI systems we know or we hear or we read about in the news are basically a black box, which means that no one actually knows how it works. You give it a bunch of data sets, which is input-output combination, and then it starts making decisions and starts learning based on that data set, right? Only recently, there have been some research happening. For example, in MIT, they built an AI model, and they were able to make the AI model rationalize how it makes decisions on this data set, right? But again, those studies are really primitive, and it's going to take some more time to generalize that to a larger audience. So for now, basically AI is a black box. So how do we ensure they have diversity and they ensure they're not biased, right? So that's where we're going to talk about testing AI-based systems. So there are three things you want to consider when you're interacting with these AI-based systems and make sure they're diverse. The first thing is having a more inclusive data set. So to explain this concept with more clarity, let's just go back, 3 or 4 years before, I think, Google Photos came up with an AI model where it started categorizing different images automatically in different folders. And what happened was this AI model, which they introduced about 4 years ago, started categorizing images of African-American people as gorillas, right? Similarly, there's another company called Beauty.ai, and they built an AI model to judge a beauty competition, and it judged only people with fairer complexion as beautiful, right? So why did these problems happen in the first place? That's because they didn't have inclusive data sets. So for these applications, if they had images of not only people with fairer complexion, like people with brown complexion, people from Asia, people from Europe, then if you had different types of these images and then trained the AI model, probably problems like this could have been averted, right? That's why having inclusive data sets is really, really important. And we as developers and testers need to ensure that when we interact with these systems. The second thing we need to think about is having an auditing process. So there needs to be a group of people who constantly ensure these data sets, which we're feeding into the AI model, are diverse and there's good variation in it. And we also need to ensure the decisions the AI models are making are also what is expected, right? Because you don't want an AI-based system getting into production and then it's not what the consumer wanted it to be, right? So you probably want to have a group of people auditing the whole learning process, you know, on a monthly basis or a quarterly basis, right? So having an auditing process helps to put some guardrails in place. And finally, testing for adversarial attacks. So just like SQL injection, even AI-based systems are prone to attacks. So for example, going back to the Google Photos app, so you could modify a couple of pixels in the images you're feeding into the AI model and skew the learning of the AI model so that it starts making wrong decisions, right? And if you, and with this, if you release the app in production, then it's going to, you know, work in unexpected ways. So that is one example of an adversarial attack, right? Similarly, you have a couple of more things you want to think about in terms of adversarial attacks. So if you go to the next slide. So recently, probably some of you would have seen this news about like 6 months ago. They fool AI-based cameras by wearing t-shirts like this. So when you wore t-shirts like this, it started seeing patterns and it couldn't recognize that this image was an image of a human being, right? And they were able to successfully fool the AI-based model 79% of the time, right? Which is crazy. So this is one edge case you want to think about, right? When you have different systems, especially facial recognition systems. So this is one example of adversarial attack. And just a couple of more I wanted to cover just to give you a good example is, so first one, say you have festivals like Mardi Gras or St. Patrick's Day, right? At least in the US, those are like two big ones. You're going to see people wearing costumes and dresses like this, right? And funky glasses like this. And say you have an AI-based like image recognition system or an app. Is that system going to recognize this as a female, right? Because is this glass going to skew the recognition of an AI model, right? So that is one edge case. So you need to think about things like this. And finally, another really good example, which I talk about is, say you're training autonomous cars, right? What happens if your autonomous car sees a stop sign with graffiti and stickers on it, right? Is it going to stop or is it going to continue to keep moving, right? Those are the things we need to think about in terms of edge cases and ensure there are no biases in AI-based systems. And talking about biases and AI-based systems, it also comes with a set of challenges. So just like any other system, you have some challenges. So if you go to the next slide, I quickly cover 4 main challenges, which are pretty popular right now and people hear about. So we have deep fakes. So recently, for example, they had a video of Obama saying something. It was on Twitter, but it was actually not him saying it. The video was not created by him. It was an AI model which synthesized that video, and it looked as if he was saying something. So deep fakes is a big problem where they're using AI models to make videos of people not saying things which they are not supposed to say, right? And then you have surveillance of citizens. So recently, a study was conducted where out of 175 countries, 76 of them use some sort of surveillance on citizens, right? When I say surveillance, it's facial recognition, location tracking, so on and so forth. And of course, US, Germany, China, those are included in those countries which are using surveillance. So unauthorized surveillance of citizens is a big challenge which people are actually working on right now. Then you have fake comments. So you can start generating fake comments on social media just to create problems for different people and different organizations. And AI-based systems are actually pretty good in doing this right now, and that has been a big challenge. And finally, spam and fraud. So you can generate spam and fraud using these systems as well, right? So we talked about different ways to think about diversity and including diversity in AI-based systems. We talked about the challenges. Finally, I just want to talk about some of the organizations which are trying to make sure there's diversity and less biases in AI-based systems. So one is, as the slide was showing, we had the IBM AI Fairness Toolkit. It's an open source library by IBM where they provide 10 mitigation algorithms, bias mitigation algorithms, which you can include in your AI-based system to ensure, there are lesser biases when you release it in production. And they also have different metrics, about 70 metrics, which you can evaluate your AI-based systems before you release it to consumers. And you also have some nonprofit organizations which are working on this aspect. So if you go to the next slide, and quickly just wanted to talk about a couple of organizations here. My favorite is the Future of Life Institute. So this was started by Max Tegmark. He's a professor at MIT. He started this nonprofit organization in 2014. He also wrote a really good book called Being Immortal in the Age of Artificial Intelligence. I highly recommend that book as well. But the point is, this nonprofit organization has hundreds of projects and hundreds of researchers working on projects to ensure the existing AI-based systems and the ones which are coming up in the future do not cause harm to human beings, right? And this organization has some of the smartest people in the AI field. You have Stuart Russell. You also had the late Stephen Hawking, who was part of the group. And Elon Musk, about a couple of years ago, funded $10 million of his own money to fund research in this nonprofit organization, which is Future of Life Institute. They also have a newsletter, so if you subscribe to it, you're going to hear a lot of news about how AI biases and diversity has been applied to current systems. And just quickly talk about a couple of more organizations. The WebTap project from Princeton is another one where they constantly monitor web traffic and ensure that companies are using data for the right reasons and they do not compromise user data. And that's an open source project. And finally, you have really good conferences talking about these issues, which we are kind of mentioning in this webinar. So you have the AI for Good Summit, which is really popular and something we're checking out as well. So hopefully that gives a quick overview on how we as technologists can prevent biases or reduce biases and make sure AI-based systems have some sort of diversity in them. And to talk more about it, I'm going to hand it over to Davar.
Amazing. Thank you so much. And I think you mentioned Stephen Hawking's, and I want to say, one thing that he said that really inspired me is we need to pause and work on beneficial AI. And I think all of the examples that you have given, AP, Kashyap, and Raj, really point to the fact that this whole industry is moving too fast for being able to be relevant to a global community. And so what we're doing at IVOW is we're an early stage startup, and our AI platform optimizes culture. So what that means is we are tagging culture. The nucleus of our technology is a culture graph, which is looking at festivals, food, holidays, and being able to create APIs for clients for them to have more culture fluency when engaging with consumers. We're part of a DC incubator, and we're building our alpha. And I'm really honored to have been sort of brought under the wing of the testing community, because as a former NPR News senior producer for many years, I know that testers are really the front lines to the public. So the last person who's going to touch something is, AP at Guardant Health before a consumer is going to experience it. And so I value your craft, and I want us to work together in this new arena around cultural intelligence. Next slide. So we're working on data set challenges, and as everyone said, we need to create new data. The first one we're going to focus on is women in history, which I'll talk about a little bit more, and then health and heritage, which is very relevant again to the work that AP is doing. Being able to come up with more clinical trials that are relevant to people of different communities and backgrounds is really important to have new data that talks about people's backgrounds and heritage when it comes to their healthcare. And then indigenous knowledge and ancient texts. This is something that we're actually presenting at the AI for Good Summit in Geneva in May that Raj mentioned. We have 3 Native Americans from Cherokee, Crow tribe, and Navajo traditions who are going to be talking about the need for an indigenous graph to be able to look at how ancient knowledge has inspired many things from the food that we eat to its nutrition value, and all of these can be traced back to amazing sources of wisdom. And then people on the autism spectrum, think about what Raj was talking about with autonomous cars. It's really important that we understand people with disabilities, and we're able to also have these stories about how people experience technology differently be part of our data sets. And stories of refugees, obviously, in the next few years, as communities, especially United Nations, is thinking about how to house refugees, how to grow programs for them, data sets are going to become essential when you think about these smart cities and smart engagements that have to take into consideration people from many different backgrounds. Next slide. So the algorithm for stories on women is going to be an effort that actually AP and Kashyap are also leading together with me and Anna. So I'm really grateful to Anna, of course, of Testmaster Academy for doing these webinars and coming together with this testing community to talk about why we need to really become specialists in this area. And so when Raj talked about needing to have better auditing processes, I think having testers be part of editorial boards, having testers become more experts in AI and ethics or AI and bias, it's just going to make all of you and your community a lot more valuable in your own boardrooms to be able to talk about why the kinds of work that you're doing for clients could be much more powerful if you were really present and informed about these needs. Next slide. So today in Geneva at the United Nations, there is an event. AI Commons is holding a roundtable. This is part of the AI for Good Summit, and they are discussing our dataset challenge today. I'm really excited that we're part of AI Commons. The idea here is for our ultimate methodology and the final algorithm that wins to be showcased in AI Commons as an example of how you can go about creating data sets, and other people who want to create them can use this as a model. So as you see, the challenge is for participants to develop an algorithm that can generate a character profile when provided the name of a prominent female in history. This goes back full circle to what Kashyap was demoing. So Draupadi, did I say that right? Draupadi?
Yeah.
Draupadi. So who is this person? Why don't we know about her? Okay, she is an epic female pioneering feminist in the Hindu culture, mythology. So I want to know her, and I also know that people have been inspired by women in many different contexts and cultures, and these women are lost to history. So they might have a statue, but why can't we, as part of this challenge, the statue of the one pic that Kashyap showed, right? Because then women can go and visit these places, or anyone in the world, and be inspired by these women. They're not lost to history. They are objects that are tagged in meaningful ways for the preservation of culture. Next. So as I mentioned, this is the first of 10 global challenges that we'll be doing to introduce the concept of AI and culture and advanced cultural IQ in AI systems, a vital part of giving cultural context to AI models. We obviously want to make sure that this algorithm is also reproducible, as I mentioned, so that others can learn from this experience. Next slide. So Anna and Aprajita, we've decided that we wanted to come together and do 5 webinars, which are divided into different topics. Today, this one was really like, you know, what is AI, what is machine learning, what are neural networks, and why do we need diverse data sets? The next one, which is in February, will be on data and security. And so we're gonna have some really amazing speakers who are gonna be dissecting that. And next slide. So we are looking for partners and sponsors for our first dataset challenge, focusing on the stories of women. So if you're interested, please step up, go to your companies, and we're looking for $150,000. And I calculated if 5,000 people gave us $25, we would be able to run this challenge. It's not a lot of people, and that's not a lot of money. We do have founding friends. So Comtrade Digital Services, a conference that Raj and Anna and I spoke at in Ireland, they're one of our founding friends. Obviously, Anna Royzman is one of our founding friends, and some others who have donated $25 because they believe in this. So we're hoping to actually launch the challenge in September and have the winners announced in 2021. And next slide. Yeah, so looking forward to any of your questions for AP, Kashyap, Raj, and myself. So we have, Anna, what's the best way to see if anyone has questions?
I'm watching. I don't see the questions right now. I have a question for Aprajita. Aprajita, so you got the introduction to the machine learning. Is that something that easy to learn? Is it like, how easy to general population of testers? I know that we had like automation was like a must-have for everyone. Now is after artificial intelligence, is it a must-have for everyone in the future?
This is how I'm going to put it. I think for testers, it's very important, like even for me, even if I was to automate something, I first need to understand the core of it, right? I need to understand how that application works. Raj kind of pointed to this. What I covered was very, very basic of AI and machine learning. It's good to have that understanding so that if you're sitting with a developer or if you're in a company, you can ask these questions. Most AI systems that are in production are quite complex, and you can't really pull them apart into like, this neuron is doing this, and this is the weight, and this is the bias, right? But it's really important to be able to understand those terms and have a conversation with the developers and the rest of the community. It is not hard to learn. It might be outside your comfort zone, but I don't think there's anything that you cannot learn. You have the best AI system in the world. Come on, you can learn it. I know Raj was mentioning there's Udemy courses that are available. There's enough sources on the internet. If you're interested in this field, I would absolutely go and look at some of these courses and take them.
Yeah, I wanted to.
And I just wanted to add to what AP was saying. So we have a deep learning course in Coursera, and it's done by Google, that really helps in learning the basics and the nitty-gritty details about how these algorithms work. And of course, you have Andrew Ng, who's like the godfather of AI, arguably. He has a course called AI for Everyone on Coursera, which goes on a really high level on how AI applies to business in AI-based systems as well. So those are some courses which personally helped me, just to add to what AP was saying. So that could be useful.
Cool. I know we have a couple questions. I wanted to put in a plug for Kashyap. I met Kashyap when he was 14 at a NASA hackathon. He's now 16, I think, or 17.
17, yeah.
Yeah. And he also teaches AI through the Princeton Community Center. And I think at one point has had 10,000 students. So we'll make sure that we put those links in for the, for the attendees to look at. And there were also a couple other questions where I guess, Raj, someone wanted to know if you have the name of the book that you mentioned.
Yep. I just replied. The book name was Being Immortal in the Age of Artificial Intelligence 3.0 by Max Tegmark, and I put that on the chat. That's the book I was referring to.
Okay, perfect. And then Lauren is asking, is it possible to post the fundraising information on your LinkedIn? Yes, there is a site, and I'll actually put it in the chat, but I will put it in our LinkedIn. Another question is, as a tester, how can I start learning AI and what steps should I take? Kashyap, do you want to take that quickly, and then AP?
Yeah, of course. AP and Raj were talking about this a bit earlier as well, and there are actually tons of information on the internet and on YouTube as well. That's where that's how I learned AI. I didn't have any like formal college training, etc. I mean, not in college yet. So I was just on YouTube. There are many courses from like so many people, because AI is such a hot topic right now. So you can start off as, just AI 101, machine learning 101. And Raj mentioned the machine learning course by Andrew Ng. That's a great one, the deep learning specialization as well. So for free from YouTube, Coursera, and Udemy, these three things you can definitely search and find. And there are many links, and it's such a big community that, you can find it online as well. Like they'll give better suggestions for books and courses as well, if anybody else.
And I'll add to that. And as a tester, what's fascinating to me is a lot of people are working on building these things, right? So one example was what we showed for TensorFlow, which had that implemented. So as a tester, I would this is what I do. It's quite fascinating is I would take an already existing AI model, I'll pull that down, and I'll run it through some of the stuff that I think would break it. Generally it breaks it. And so it's then fun to know, what are the things that you might want to consider when you're testing an AI model. The free, online code that you would find, they're pretty simple. Not as extensive as production applications, but it really gets you thinking on what are the type of edge cases, some that Raj pointed out, especially for image recognition, that you can use.
Great. There's a question about, there's an understanding that AI will replace a substantial amount of jobs, but it will also create new jobs. So how do you think jobs will evolve over the years? Could you, Raj and AP, talk about that in a context of testing?
So I could share one study which I found. So McKinsey found that by 2030, the AI value creation is going to be $13 trillion. So whether you like it or not, so AI is going to be used in systems. That being said, I think the more impact in terms of jobs would be in the more of the blue collar sector, mainly in assembly plants and things where there's automated processes which needs to take place, or for example, manufacturing plants, and then even cars, like Uber drivers, those kind of jobs are probably going to get replaced. And but I think in terms of people in technology and development and testers, they would still need us no matter whether the systems are AI or not. So that's my take on it.
Yeah, and I'll add to that. So remember, before you ship something to production, right? Even today, forget AI or not, you have a software, you have any machine. Before you ship into production, it has to go through multiple iteration of development. And we've demonstrated enough, I think, just through this webinar, that AI, just because it's a machine learning algorithm, it doesn't mean it's going to function or work perfectly. It has to be tested. We haven't seen as much, actually, we're starting to grow in that field now. And that's why it's so hyped up right now. So I don't see a decrease in value for testers or developers as we go in that area. We would need more of this knowledge in order to produce better AI models and include some of the aspects that we've talked about, like data and security, and also just being able to recognize things like, does your AI model is able to detect, your car is able to detect a stop sign that has stickers on it. That's a great example, right, that Raj gave. So all of these things, who's going to think about them? You need to be there in order to think about them. So I don't see that declining in any way, but it goes back to the fact that you need to start learning about these things so that you can grow your knowledge in AI and machine learning.
I believe there was one question unanswered from Suresh. Do we have inclusive data sets defined for domains, healthcare, retail, digital ordering?
Can you repeat that, Anna?
Do we have inclusive data sets defined for different domains? For example, a healthcare domain, a retail domain, digital ordering domain. Are those data sets already defined?
So there are data sets. I don't think these are global data sets. Companies that are working on healthcare or other areas, they have, they might use common data sets that's out there. So for example, I work in the field of genomics. And so there are plenty of data sets that are out there that have inclusive or sort of inclusive data. The problem to inclusivity is two. One is, if most of the research, say for example, is happening in the US or in Europe, then the data that you're going to see is people who are European or American or Caucasian population. You're not going to see as much Asian data, or you're not going to see as much Middle Eastern data, for example, right? And so if those are important for your data, like in genomics it is important, then you have to be aware of that and you have to include it. But that's a very broad question. I think it would really depend on the product or the company that's making to decide whether that data set is inclusive enough. I don't think they are very inclusive. We are going there though. Does that answer your question?
I believe so. Thank you very much, Aprajita. I believe we ending this webinar. It's been an hour. It was very informative. Thank you so much, everyone. It was a pleasure meeting all of you. I hope that our participants and attendees will keep in touch and attend our next webinars, because we're gonna cover a lot of different topics. And thank you all panelists. Today was an amazing time.